Hi everyone, today I want to present article diagnostic of the electric field in Sprite. I'm Jenny Guo from the National Central University in Taiwan. This research purpose is to analyze the auditive profiles of Sprite emissions blue and red to derive the electric fields. The spectral photometer diagnostic of Sprite is interesting because the major emission ratios can infer their energy and the ionization ratio and the electric field in the sprites. To validate the sprite streamer theory in different altitudes with approximate exciting rate, ionization rate, and the Einstein rate and the quench ratio and others, we using our observation results of blue and red emissions in Sprite to derive the electric fields using the Sprite streamer theory. Introductions. Recently, the space missions for the sprites, including SIN missions, and several years ago there is a Japan missions, Jim Greens, is conducted by the Professor Mijus. This experiment are scientific instruments on board the International Space Station. They're using the nadir view for the sprites. But about 10 years ago, there's issue missions in 2004 to 2015. They're using the satellite observations. They provide a limb observation. So we can use this data for altitude profile analysis. This will show how the sprite emission we observe in the issues. They have an image. We take the image here. There is sprite and the thunderstorm emission. For the limb observation, they can easily separate this emission from the lightning. And we have blue and red emission for the second party and first party of molecule nitrogens. Using these emissions ratios, we can compare to the sprite streamer theories and to derive their electric fields. Article diagnostic of sprite streamer theory. In last decades, they have a lot of advanced studies. For example, for this paper, they identified the non-uniform sprite streamer. They can explain why using a different emission band, they have a different result. For example, for a Dutch, they estimate lower electric fields, and for other bands, for example, the Guo and the Liu, they have a higher electric fields. It's about 3 or 5 times or breakdown electric fields. Compared to the ground observation, they're using magnetic fields, and they can calculate the electric field. And we will compare later. We using the sprite streamer theory to analyze the sprite blue and the red emission to derive the electric fields. Here we using the three ratios. Region 1, we only use for the local electric field produce the emissions. The second one, we consider our instrument time and the spatial resolution, so we need to integrate these emissions. The third one, region 3, we further consider the spice streamer theory with the growth rate for the different altitude. They have a different neutral density. Here is a region 1 for the derived from the typical emission equations in Sprite. And we're using this equation to derive the local emissions. And the second one is we consider the spatial and temperature integrate effect. The third one is we consider the spike streamer will be from the high altitude to a low altitude. They will expansion. This expansion is corresponding for the growth ratios gammas. Here is our considered parameters for example, for ionization rate, touch rate, and the lifetime for the first velocity and the second velocity, and for the exciting rate, and for the Gaussian rate, gamma. Here is a Sprite halos here. We can find this one is for a 0.4 breakdown electric field. This one is about a 1, and it's about a 4 breakdown electric field. So you can find the Sprite halo is between the 1 and the 4 times the electric breakdown fields. But for a Kilo Sprite, we are supplied for a lower value electric field here, derived from the Sprite emissions. And we collect more events. We divide these two types for the Sprite halo events. They have higher electric fields. But for the Kilo Sprites, they have lower electric fields here. We further consider one case is for the density Sprite. For the first Sprite, they have a higher value for the electric fields. But the later one, maybe the plasma environment changes, so they have a lower value. So plasma density change may be cause the Sprite emission have a lower estimation. Summary. In our study, we select the Sprite events using the blue and the red emissions to our study compared to the Sprite streamer theory. But here we found the Kilo Sprite events. They have a lower electric field, but for the Sprite halo, they have a higher electric fields. Because extra ray emission may be contributed from the node streamers emissions. For example, for the Sprite beats and the Sprite growth from the Kilo Sprites. So also the plasma environment changing may be changing the derived value of the electric field from the Sprite emissions. The computer paper you can download on the website for this link. If you have a question, you can ask me by this email. Thank you, everybody. Finally, we have announced for the call for papers in NDPI Atmosphere Journal. The deadline is next year's March 1st. We include TLE research, transducing event spy, blue jet, gigantic jet, and else. And we also consider thunderstorm, lightning, and other gamma ray flash starting. If you are interested, you can go to this website to submit your paper. Thank you.